Just wanted to do an example of using SALT at the beginning of 6.5. So this question, we'll just look at this one. Suppose X has a distribution with a mean of 70, standard deviation of 45, and that is a sample of 36. So since we have over 30 in our sample, we can describe the X bar distribution and compute the mean and standard deviation of that. And this was completed correctly, so make sure you have those formulas down. It is approximately normal. The mean is 70. The standard deviation, when you compute that, will be 7.5. And then it says find the Z value according to X bar equals 62.5. So what you can do there is you can click on SALT. Again, we're looking for Z when X is 62.5. Remember, we had a mean of 70, I believe it was, and a standard deviation of 7.5. And we want to know what the Z-score is down here at the bottom when X is less than 62.5. Okay, so if you just plug that in, you'll see here that the Z-score, you can see that here, is -1. So that is our answer here. The Z that corresponds with X bar being 62.5 is -1. And then we need to find the probability that X bar is less than 62.5, and they want us to round to 4 decimal places. So if we'll come up here, we'll go the probability that X is less than or equal to 62.5 is this number here. Round to 4 decimal places, that'll be 0.1587. Okay, so 0.1587, here's that correct answer there. And then would it be unusual for a random sample of size 36 from the X distribution to have a sample mean less than 62.5? Well, the probability of being less than 62.5 is about almost 16% here. It's 15.87%. So no, it would not be unusual because more than 5% of such samples do have means that less than 62.5. So this is, if you move the decimal 2 places to the right here, you will find that the probability was 0.1587, but that essentially means that 15.87% of all of them were less than 62.5. So I hope that helps.